morning, children. Today we are going to start with the chapter electricity, and this is a general introductory class for the electricity, in which the main attraction will be the drift velocity of the electrons. And in order to understand electricity, you already know about it. Just recapitulate the things that we are taking care of. Here we have taken the electrons. So you suppose if you take the case of the conductor, then you really find that this is the positive terminal and this is the negative terminal. So what exactly you find that there is a flow of electron from negative to positive. The electrons flows from negative to positive, but the current is flowing from positive to negative because this positive is at the higher potential and negative is at the lower potential. So what is being created, a potential difference is being created. As a result, the current flows from positive to negative. Okay, so here what is the necessary condition for the electricity to flow is the potential difference. If we have the potential difference, there will be a net flow of current. If the potential difference is zero, then the current does not flow, because here the potential difference between the two ends does not exist. Potential difference becomes zero and there is no flow of electron from negative to positive end. As a result, there is no flow of current from positive to negative. So this is the basic idea about the flow of electricity. Now the basic formulas that you already know is about the charge. Q is equals to I into T. Here Q is the charge, I is the current, and T is the time taken. So these are the basic things that you already know about it. So here we will understand more about it with the free electron theory of conduction. And when we consider the free electron theory of conduction, so we will consider a conductor. Here the conductor has been taken and the conductor is of length L. The length of the conductor is L. And here if it is what is being seen, that the average, when there is no external cell added, then what is being seen, that the average velocity is becoming zero because of the random motion of the electrons. But the moment there is a external cell which is being connected to the ends, a potential difference is there very well, and the current flows from positive to negative, and the electrons which are inside the conductor, initially they were at rest, but once they get an external source from outside, so they are accelerated, and as because of this, they just start flowing opposite to the electric field, because the electric field is from this end to this end. The direction of the electric field is this direction, but the flow of electron is just in the opposite direction of the electric field. So it simply gives an idea that the electrons are being accelerated. Now when we talk of the acceleration of the electron, there are two things that we need to know. One is the relaxation time. So what is relaxation time? It is the time taken for the successive collision of the electron. When the electrons are just moving, they collide in the path, and the time taken for the successive collision is known as relaxation time. We call it as a relaxation time. And mean free path is the distance between two successive collisions. Okay, so here we have seen that the electrons are being accelerated. Since it is having an acceleration, the basic formula for acceleration is force by mass. So force is equals to the charge of the electrons and the electric field. E is the electric field, E is the charge of electron. This is divided by m, the mass of electron. Okay, so here we have the relation E is as that. So if we want to relate E with the potential difference, then we know that E is equals to V by L. So when we write E is equals to V by L, so A is equals to small e. Instead of E, V by L is written. So here we get E, and this is V by L, and this is ml. So this becomes the formula for the the acceleration of the electron. Further, it is being seen that when we talk of the flow of electron, that is in terms of the drift velocity, then the potential difference, we can very well see that the potential difference is not depending at all upon the acceleration. That is, it is does not provide an accelerated motion to the electrons. But here it is giving an idea that there is a small constant velocity which is very less, of the order of few millimeter per second along the length of the wire, and this is in the opposite field to the electron. Now this is what we call the drift velocity. Now we have seen that this is actually an idea. We will just define drift velocity a little late. So drift velocity, in order to get it, we have the formula v1 is equals to v is equals to u plus at. Here v1 is equals to u is the, since the electrons are starting from rest, so we get this relation as 0 plus 8 tau 1. Tau is the relaxation time. So if we consider all the electrons, if we have so many electrons, because there are so many electrons inside, so let us assume that there are an n number of electrons. We have got n number of electrons here. So for all electrons we have the general formula, that is v1, that is we can very well see that v1 plus v2 plus v3 dot dot vn is equals to a tau 1 tau 2 that were divided by n. So this gives the idea of the drift velocity, that it is the average velocity of all the electrons having that sort of constant one, which we already stated. So this is drift velocity. Vd is the v suffix d becomes the drift velocity. This becomes a tau, that is the relaxation time. Now if we have this as vd is equals to a tau, so acceleration is what, f by m, and again it can be written as small e capital E by m tau. So this gives s equals to e tau by m if we write. Now this is what we call the mobility. So if we want to write for the mobility, we have the formula for the mobility as equals to e tau by m, and this we can very well see that the drift velocity is equal to mu e. This is mu e. This is the relation that we are getting for the drift velocity. That is the relation that we get for the drift velocity. Or we can very well write mu e as equals to, mu e is equals to vd by, we can very well write mu e is equals to vd by e. So this is one of the relation that we have got for the mobility. This is for the mobility of electrons. Mobility of electrons. How it is related to the drift velocity, how it is related to the drift velocity. The next, again very important thing, that we need to understand the relation between the drift velocity and the current. So in order to find out, we'll take a general formula. What was the general formula? We will write q is equals to, we will write q is equals to what? It is the general formula we have got as the number of electrons. We write number of electrons into charge of electrons. Charge of electrons. Okay, so here we are writing up small n, but small n is not the number of electrons, but it is the number of electrons per unit volume, and this is E. So we write n as equals to number of, n is number of electrons per unit volume. When we talk of volume of the conductor, then the volume of the conductor is equals to what? Area of cross section into L, that is the length of the conductor. So here we have the condition that if we have that condition for the electrons, then we can very well write this as equals to q is equals to, n is the number of electrons multiplied with the volume, this becomes AL into E. Okay, and q is equals to I by T. Q is equals to I by T. Q is equals to IT, sorry. Q is equals to IT. So this becomes equals to N A L E. So we can write I is equals to N E A. This is E